Hello, everyone. This is Munmun Choudhury. I am an associate professor of interactive computing at Georgia Tech. It is my absolute pleasure and honor today to have the opportunity to speak at IC2S2 this year, and I deeply appreciate this invitation and for you to be here today. My talk today will review some of the work that we have been doing at the intersection of social media and mental health over the past several years. And hopefully, it'll provoke you to think how an action research lens from the social science field can provide richer, deeper, and hopefully more useful outcomes to computational social scientists. So, as you know, powered by the data and other digital traces that people leave behind on different, online and social media platforms, over the last decade or so, the field of computational social science has made a lot of very significant strides into improving our understanding of a variety of different social phenomena. These data have provided new ways for us to measure our social interactions, our moods and emotions, our political ideologies and stances, as well as our collective action. In fact, computational social scientists have also made a lot of contributions to improving our understanding of political events and outcomes, different crisis events, health and well being, and also our civic engagement. In the light of this talk, let me take this opportunity to share with you some of the highlights of the work that my collaborators, my students, and myself have been conducting over the past few years. And our goal here is to improve our understanding of well being and mental health and how these types of online data that comes from thousands and millions of individuals can actually augment different provisions that are made to improve mental health care and access among individuals, communities, and populations. All right. So, in one of our early works, we focused on the individual, and in this space, what we sought out to do was to test the feasibility that social media data may provide in gleaning meaningful insights about our psychological state and our forthcoming risk. So, for instance, in this work, we looked at new mothers who use social media platforms such as Twitter and Facebook, and we tried to understand what kind of behavioral and effective indicators can we get by looking at people's social media activities and how that information could relate to risk of postpartum changes and depression in these new moms. What we found in this work is that by looking at social media data spanning several months, we can get many meaningful insights about people's social interactions, their levels of activity on these platforms, the nature of emotions that they express on these platforms, as well as their interpersonal focus and temporal orientation. And in fact, what we found in this work is that by looking at Twitter and Facebook data, we can not only identify that about 15 to 20 5% of new moms who use these platforms do show some indicators of significant postpartum changes in their mood and behavior. But in fact, we can use these insights in a predictive modeling framework that would tell us the risk of postpartum depression several months ahead of time. All right, so let's talk about communities now. So, communities are a slightly different granularity compared to the individual, but still, the data that communities leave behind on social media platforms can still have a lot of value in helping us understand the experiences that different members may have at different points in time and subject to different types of incidents that these communities might experience because of their situated nature. So in this work we looked at college communities and we looked at gun violence incidents as a type of negative set of incidents and crises that are experienced by college community members at different points in time, and we wanted to see how we can look at social media activities of college communities and what it can tell us about the psychological distress that these communities face over time. So, looking at 12 incidents of gun violence over 12 universities over a period of 5 years, What we found in this work is that there are many meaningful signals about the community as a whole that we can get by looking at the language that is shared in different conversations of the members of these communities. In particular, what we noticed in this work is that we can build supervised machine learning models that can assess the levels of stress that are expressed in the conversations in these college subreddits. And this level of stress increases in the periods after these gun violence incidents relative to the levels of stress that we see in the period before. In fact, the changes that we see seem to be quite stark and different compared to the levels of chronic stress that we might expect to be prevalent in a college population at a time period when there are no such crises. All right, so finally, let's talk about the population level granularity. In this work from a few years ago, we had developed an index to measure depression over a certain geographic area in a near real time fashion. The idea here was to leverage a supervised machine learning classifier that we had built in some of our prior work that would assess levels of depression based on the postings that are made on a Twitter timeline or another social media platform feed. We had validated that supervised machine learning algorithm against standardized screening tools of depression, and we found promising concurrence and convergent validity of our method. So this is what we can do with this depression index that functions at the granularity of a large population. If you notice the two pictures on this slide, on the right we have the levels of depression that are assessed based on our social media depression index, and on the left you have the actual rates of depression that are noted in the data of the Behavioral Risk Factor Surveillance Survey, which is a survey that is run by the CDC every few years to assess different mental health conditions. What we find by comparing these pictures in the slide, both visually and statistically, is that there is a strong convergent validity that we can assess from our social media based depression index. And this kind of a measure can not only help us augment the kinds of survey assessments of depression that we can make, but it also can provide us insights in a near real time fashion, telling us about seasonal trends of depression, about diurnal trends of depression, as well as how depression experiences vary depending upon the sociodemographics of different subpopulations. Okay, so now that you have heard about these three different research problems and their solutions that can be provided by looking at social media data, you might be wondering, so what is the next step in this line of work? Are we ready for real world deployment or use of these models? And what would be the best way to do that? So, I believe that the most promising potential use of these insights would be to connect people in need and those who are in distress with timely and proactive help. And this could be in the form of technological interventions or other kinds of platforms, tools, interfaces, and apps that could be built that are powered by the insights given by these data and by these algorithms. There's also a lot of potential for community organizers and other stakeholders, as well as public health organizations, to harness these kinds of algorithmic insights to influence policy that they might be framing, their budgetary decisions, as well as their decision making going forward. So now the question is, so what is preventing us from pursuing these directions, right? All right. I would note that there are three issues that we need to pay attention to and address before we can realize the potential of these data and the algorithmic insights that they provide. First of all, there is the issue of agency and power. How do we offer these desired attributes of agency and power to the people whose data we are analyzing and the people who are at the very center of potentially benefiting from the outcomes of these algorithms? The second issue is that of unintended negative consequences. What do we have to do to ensure that the research products that we develop and deploy in the real world are not used in a way that harms ultimately the people who we thought we would be able to benefit? And then there are broader questions of ethics. How do we consent people? What provisions we should have to prevent adverse outcomes? How do we protect a vulnerable population who is subject to this research? What is the social and moral responsibility of the researchers in minimizing harms? And the list goes on. Ultimately, what these questions point at is the need to consider agency and power, unintended negative consequences, and ethics as a part of the research process itself, instead of as an afterthought. So, in the remainder of this talk, I will present a theoretical lens we can adopt as a computational social scientist to make our research both rigorous and ethical, as well as practical and actionable. So, this particular research lens that I'm talking about is called the action research framework. So, a lot of the qualitative social scientists, if you're in the audience, you know what I'm talking about. So, to the others, action research, it's a philosophy, is as much a philosophy as it is a methodology of research in general. It is applied a lot in the qualitative social sciences and anthropology and ethnographic work. It is actually a pretty old framework. It was coined by a social psychologist called Kurt Lewin in 1944. And what Lewin said in his work is that this approach, what it does is it seeks to have transformative change, and it does so by sort of an iterative, simultaneous process of both taking an action in the domain that you're working on, as well as doing research around that action. And both the action and the research are in some ways are linked together by critical reflection. So, in essentially, what action research does, it uses a spiral of steps. Each of these steps is composed of planning, of action, as well as the research part, the fact finding part that happens as a result of the action. So, now why and how is it relevant to what we are talking about? So, let's go back to these three things we discussed: the agency and power issue, unintended negative consequences, and ethics. If we have a way to iteratively engage the key stakeholders as a part of the research process in a collaborative and participatory way, and we take actions surrounding the research in a way that is guided by these stakeholders, it would help us in overcoming some of these difficult ethics and related challenges. So now the challenge is that there is no formal guidance on doing computational and machine learning type of work with an action research paradigm. Like I said, it is largely prevalent in the qualitative action research, qualitative social science field. So what I'm going to do in the rest of the talk today is I'm going to talk about how we adapted and adopted this lens as a way to collaborate on a shared goal, on a shared mission that we had as researchers, and what our team shared with specific organizations that we partnered with in the projects that I'm going to discuss. Okay, so let me get started with this first example of the two projects that I'm planning to talk about that uses the action research framework. So this project is a collaboration. It's an involved, intertwined collaboration that has been going on since 2017 between our team at Georgia Tech and Northwell Health. Northwell Health is one of the biggest healthcare systems in the state of New York, and they have a psychiatric research center, as well as treatment clinics throughout the country, as well as in New York, that provides cutting edge care related to a number of different mental illnesses. So the project that we are working on together is called Thrive, and the broader goal of this work is to see what kind of signals can we derive from the social media, online, and other kinds of data that can be voluntarily shared by mental health patients, and how can this information be made actionable using machine learning and other computational tools that will be useful for clinicians as well as patients, both in order to tailor treatment better to the needs of the patient, but also to improve functional and clinical outcomes in the lives of these mental health patients. Oftentimes, these are individuals with serious mental illnesses such as schizophrenia and bipolar disorder. One of the key questions that has been central to this collaboration has been the question if we can predict relapse in mental health patients by looking at their social media data. Let me give you a little bit of a background why this is an important question. So, for many serious mental illnesses, such as schizophrenia and bipolar disorder, they can be associated with significant impairment. But what makes these illnesses even more challenging is the fact that for individuals who are under treatment, even for them, up to 80% can experience at least one relapse within the first 5 years. As you can imagine, each new episode of relapse is associated with multiple emergency room visits, psychiatric hospitalizations, family burden, medical complications, and sometimes even suicide. The unfortunate reality is clinicians have very little handle on understanding relapse. Oftentimes, they get to know of these incidents after they have already happened, when the patient is hospitalized or the patient comes back to see the doctor because of significantly worsened symptoms. So, what has come up in our discussions and our collaboration so far is that how do we change the status quo? In this case, changing the status quo would mean to give the clinicians a prospective understanding and knowledge of the risk of relapse in a patient so that they can use that information in an evidence based way to tailor treatment and to trigger appropriate interventions. So, as you can imagine, patients are a very important stakeholder in this research. It is ultimately them whose data will power the investigations and who will ultimately benefit from the models that we develop. So, under the action research framework, fortunately, this framework includes flexibility to incorporate such stakeholder views within the research process itself. Accordingly, we conducted a series of surveys and interviews with patients seeking treatment at our target medical institutions to find that there was overwhelming support for this kind of research. Patients, in particular, recognized the value that volunteering data for this work could bring to their own health as well as the health of their peers. So, following these insights, since 2018, we have been recruiting patients. We have recruited over 100 patients diagnosed with a psychotic disorder like schizophrenia, and half of whom have had at least one relapse related hospitalization. All of these individuals agreed to share their entire Facebook archives with us, giving us tremendous opportunities to undertake the relapse prediction research. So, now let me tell you a bit about the considerations in our modeling approach, which were guided through our discussions with our clinical partners as a part of the action research framework. So, relapse events are multifactorial, meaning that they can manifest in many different ways in different people. In a sense, they can be thought to be heavily associated with what is known as clinical heterogeneity. Furthermore, another consideration is that there are actually no true positive or no true negative examples in this setup of relapse prediction because any individual at any time has a non zero likelihood of relapse at a future point in time. So, what this means is that it makes it really difficult to apply state of the art supervised machine learning approaches or time series forecasting approaches for this kind of a modeling task. Another important consideration why time series modeling is not very suitable here is the fact that relapse is a very rare event. So, to counteract this reality of the data and to enhance potential use of the algorithms built on this data, we model the relapse prediction problem as an anomaly detection problem, where the goal is essentially to have this personalized approach where we are looking at a single person's Facebook data and you're looking for aberrations in behavior, in language, and in socialization that deviates from the baseline of this same individual. For our modeling, we also played around with different durations to examine how much data do we really need for this prediction task. And we found that by looking at data spanning a month prior to the relapse hospitalization, we can do a pretty good job of finding these relapse related anomalies. So now the question is, how well did we perform? Let me tell you about that. There are two metrics that I'm going to report here. The first one is specificity, meaning relapse that were correctly predicted as relapses by our model. Here we do pretty well. We achieve a performance of nearly 80%. But where we don't do so well is the second metric called sensitivity. What it means is the model thought that certain periods, which in our data were marked as healthy, the model thought that these were relapse periods. So, sensitivity in our case, we find that is only 37%. The action research paradigm allowed us a possibility to iterate over these results and rationalize and reason why we see this discrepancy in performance of our model between specificity and sensitivity. So, to unpack these results further, what we did is to look at clinical charts. These are essentially open ended notes that are recorded by clinicians at the end of every consultation with their patient. And what we found is that for the 45 of these false negatives, for about half of them, we had information that was pretty valuable in these clinical charts and these notes. In fact, for 90% of these data, we found that the clinician indeed had recorded that this individual had significant exacerbation of psychotic symptoms. Um, However, this clinician did not assess that it was significant enough that would warrant a relapse hospitalization. So the takeaways of this work is that it allows us a new way to think about how we can inform clinical treatment. We got these insights about relapse by looking at Facebook data of patients. This was data that was voluntarily shared by these patients, and through an iterative process that was supported by the action research paradigm, we were not only able to build a set of models that mimic the reality of clinical treatment as well as the reality of the experience of psychotic disorders themselves, but also the action research framework allowed us an ability to rationalize and reason about the performance of these models, and then to hypothesize under what circumstances does this model perform well, when does it not perform well, and how can we still derive benefit from the model when it is not giving us our expected results. And finally, let me tell you about the second research effort that we have been involved in over the past while that also uses an action research inspired framework. This work is based on what is now an 18-month collaboration with the Centers for Disease Control and Prevention. And here, our shared central goal has been to inform suicide prevention efforts and interventions using social media in conjunction with other types of public health signals. You may be aware that the rates of suicide in the US have been monotonically increasing over the past 20 years. But actually, in spite of the urgency of this public health problem, currently we don't have real time information on suicide fatality trends that could actually guide prevention efforts. The National Vital Statistics System, the NVSS system, collects information from death certificates that are submitted by more than 2,000 medical examiners and coroner offices in the United States. But these statistics on suicide, although they're really high quality, they're delayed by about 1 to 2 years, depending on the time point when data is queried. So this causes serious challenges for governmental agencies such as the CDC to make budgetary decisions, deploy interventions, and adapt policies for improving timely access to care, or to even design programs for suicide prevention. So, address this gap using an action research framework. In this collaborative work, we have been developing a first of its kind machine learning model to estimate weekly suicide fatalities in the US in real time, an approach that currently does not exist but has been recognized to be really critical in understanding the trends in suicides, especially the rise. So, in more specific terms, what we do in this research is to develop and validate a two-phase machine learning pipeline that would leverage several kinds of disparate but complementary streams of real-time information that could be or are related to suicides. In our case, these data streams have encompassed novel health services, administrative data, economic data, meteorological data, and online data such as from social media, search engines, and so forth. So these data sets, in our case, we identified them in an iterative way. We selected them after careful theoretical literature and domain connections. And our outcome variable that we are working with here are the weekly counts of suicide fatalities aggregated at the national level. So, what we hypothesized in order to tackle this question is that when we combine information from these varied sources, this would enhance the accuracy of estimates of suicide fatalities more than any individual data source alone. And this can really enable estimation of trends in these fatalities that can actually be practically useful to inform public health activities. The other reason for this type of an ensemble approach is that it is likely to allow countering for the underlying biases that each of these single data sources include, and because suicide outcomes are often faceted and different subpopulations often have different experiences with suicide, and therefore they're likely to be differently represented and stratified in each of these data sources. So here is a brief overview of our model architecture. At a high level, our approach, what it tends to do is to fit optimal models to each individual data source, and then it subsequently intelligently combines these predictions made from each data source using an artificial neural network. Let us quickly jump into what this architecture actually does when we try to predict rates of suicide. In terms of how this model performed, what we find from these set of initial results is that each of these individual data sets bring some value. They have some distinct strengths and weaknesses. Some of them are really good at tracking seasonality or week to week trends, as you can see in the column that records the Pearson correlation coefficient. Whereas there are others which are good in minimizing the error of weekly estimates. So the magnitude of the number of suicide fatalities week to week, and that is reflected in our measures of the root mean squared error or the mean absolute percentile error. And at the same time, we also see that there are a third category of individual data streams which are really good in estimating the total number of suicide fatalities over an entire period, that can be measured by the percent error in the annual estimated rate of suicide per 100,000 people. So the ground truth here we are working with in the year 2017, 14.47 individuals died of because of suicide every 100,000 of the population. And our best individual model here that gives the lowest error is this model that uses Twitter as the source of signal. And we see that the percentage error here is a little over 5%. So what happens when we combine these data sources? So expectably, in the results that you see in this slide, we see that all of these ensembles actually improve over our models that use individual data sources alone. Of particular importance here is the very last row of this table. So if you look at this one, when we combine all of these different data sources together, this ensemble actually outperforms the predictions that are made from the best performing baseline model. So our baseline model makes estimates based on historical suicide fatality data. And we see that this ensemble model actually improves the correlation coefficient, while it also reduces error around the magnitude of weekly estimates by approximately half, and the error for the annual estimate to less than 1/10 of that of the baseline model. So, to conclude this part of the research, there are many important implications that such an action research based framework of investigation has provided in the context of public health. First, as we've already mentioned, we currently don't have established way to gather real time national information on suicide trends, which is essential for timely suicide prevention efforts. Here, what we did is we iteratively combined information from both online big data sources, as has also been done in previous work, but here we augmented this data in an iterative way with more traditional health data sources. And what we found is that we are actually able to achieve a fairly accurate estimation of suicide fatalities in a near real time fashion that is less prone to the underlying biases, the idiosyncrasies, and the unique characteristics of any single data source. So what is happening here is essentially our approach is able to harness multiple complementary data sets in this estimation task that is robust against what has been referred to as big data hubris in prior work, a limitation that has been noted in previous attempts that have used large scale online data for public health goals. A notable example is the Google flu trends. At the moment, our research is being iterated over and deployed at the CDC. This is very exciting because it will close the loop and finally give us some evidence of the impact that computational social scientists can have to influence real world decision making and real world outcomes. The hope is that with such a model, will we be able to predict going forward when there is likely to be an upturn in suicide fatalities? All right. As someone who has called herself a computational social scientist for the last 10 years now, I want to leave you with two thoughts. First, that as a computational social scientist, we can do better than being extractive in our research approach. Most of the problems of computational social science are not just social problems that we are attempting to solve with a technical approach, but in doing so, in many ways, we are actually tackling socio technical problems. Second, that as computational social scientists, we should aspire to not just be good researchers, but also responsible researchers. Most of the problems of computational social scientists are not just inconsequential problems that constitute an academic endeavor, but instead are ones that can have a deep impact on people and society. As computational social scientists, we therefore need to be the very change agents who can inspire the change we would like to see in the world. As the creator of the action research paradigm, Kurt Lewin said, if you truly want to understand something, change it. So, in this talk, I told you two stories about how we can do computational social science with tools that the thoughtful social scientists had devised many years ago. I talked about adopting and adapting action research as a way to do computational work. Beyond the problems and the specific issues I discussed, though, there's a lot computational social scientists can achieve by using a participatory, collaborative, multi stakeholder, faceted research approach. This includes, as we do our research, paying attention to building trust in different affected communities, supporting graceful failures when our data or models cannot stand up to the potential use case, or doing no harm as the Hippocratic oath goes. The question is, what is a path forward and an approach where these questions are not just afterthoughts following a Twitter conversations with your peer or after reading an Atlantic article, but rather these are issues we consider in our very methodologies themselves. And with that, I would like to conclude my talk. Thank you very much for listening. I really appreciate you being here today, and I do believe I have a couple of minutes for questions. But before I jump into that, I would like to thank all my students, my collaborators, and the sponsors of this work, without whose support this wouldn't have been possible. And last but not the least, the organizers of IC2S2 for giving me this opportunity. Thank you.